Let's begin. So for this video, we are going to be talking about the players, how they swap between each other with the player manager, as well as inputs and blasters and bullets. So for the players, we have the AI player and the regular player. The AI player, we have its lives set off screen because we don't care about the player life count. I mean, the AI life count. They don't have lives. They just play until we start the game. And we also give it the attractor keybinds. Whereas with the player, we have its score and life based off of what's given, and then its keybinds are determined based on what number it is. It also receives from the sound manager the command for the sound whenever the player gets a 1-up. In both cases, once we create them, we will start with the new game. So what this does is it will fill up a 2D Boolean array to determine where mushrooms should be in the grid. So we will firstly take this top row. It's going to be set to true because we are going to fill it up with text blockers. And the last row we're going to set to false because mushrooms cannot spawn in the bottom row. Everything in between, we have an integer to determine whether or not it's randomly going to add a mushroom. If it does, we mark it as true. Otherwise, we mark that spot as false. And then once we are done with that, the grid will know where to populate the mushroom locations. So that will be over here. During the activate grid process, it's going to get the board state of in that position, and if that spot is true and there is not a text blocker already in that location, then it's going to create a mushroom using that board state. Populate bool I'll cover more in the grid, but the quick gist is it's going to scan the board once the blaster is dead. Anywhere that there's a mushroom, list that as true. If the mushroom is damaged or poisoned, it will add it to a list of damaged mushrooms to be processed during the regeneration stage. Whenever a player gets points, it is added to their score value. It is also added to a countdown value here, so that whenever the player the countdown, whenever it exceeds the extra life threshold, it is going to give them another life and reset it by subtracting it from the threshold. We do the subtraction instead of just setting it to 0, so that if a player gets, say, 13,000 points and the 1-up value is 12,000. If we set it to 0, then its next 1-up would be at 25,000 rather than 24,000. So by using subtraction instead, it doesn't cheat the player out of an extra life. When we increase the lives, we make sure that they don't have the maximum amount of lives. If they don't, we increment, play the sound effect, and update the life text. And when we are starting idle play or 1 or 2 play, we either reset the AI or reset the player based on the mode. This reset process sends the score back to 0, wave back to 1, and then starting lives and extra life countdown back to 0. And it also begins the new game. Alright, that's the player. For the strategist, the input strategist is created in the player manager over here. It is created here. We populate it whenever we start idle 1 or 2 player because all of these key bindings are game objects. This means that when we swap scenes, they get deleted. So every time we have to create them again. And then we can change our bindings based off of what the current active player's bindings is. So if we find the references again, see that change it to player 0, player 1, player 1. These bindings will tell the input strategist whether to move left, right, up, or down, or fire, which will then, the strategist will then tell the blaster to do the same. So if we go to the input bindings, we can see we have enable, disable, and then we also have the enum type. This is the parent class for them. The different subclasses will determine how to react to these. So for instance, the attractor mode, it uses an alarm system to tell the strategist whether to move left, right, up, or down, or if it wants to be idle, then to do none of it, right here. For the actual keybinds like WASD, it will check for keyboard inputs, and based off of the keyboard inputs, it will tell the strategist whether to move left, right, up, down, or to fire. Strategist that whenever we need to change keybinds for it, we have to disable the current active keybinds because we are using the update function. We have to make sure that the keybinds only work while the current input is active. So we disable that, and then we swap the keybinds to whatever given type we have, and then we re-enable the keybinds with the new one. So if we wanted WASD, we disable, get the WASD inputs, and then re-enable. For the blaster, we will initialize it. We default all the variables. We create the bounds here based off of the blaster offset and the size of the grid. This makes sure that the blaster cannot get outside the play space, which is determined by over here, determined by the play space offset variable, as well as the row and column size. So if I were to quickly run this, you can see that I'm moving and then I get stuck on the edges. This is because as I try and go to beyond these edges, I'm getting clamped to the boundaries. So I'm getting clamped. So that's how the blaster works. For the bullets, well, for the blaster, whenever it collides with a mushroom, it checks the position of the mushroom relative to the blaster to determine if the mushroom's on the left, right, up, or down. And based off of that, it will determine whether or not the blaster can move in that direction. So if the blaster tries to move left, then it will check to see if the mushroom is to the left. If there's not a mushroom to the left, it will update its position. Otherwise, it won't do it. It will repeat this process for all directions. So if I just quickly start up again, go to 2-player, since we're going to talk about 2-player soon. See, we cannot go past the mushroom. That quick. So then for swapping players, we will look into the player manager. First, we check to see if we're in attractor mode. So if the current player is player 0, we don't do anything. If we are not, then we check to see if we are playing with 1 player. We are not. We're playing with 2 players. So we're going to see, does player 1 have any lives? They do not. I mean, they do, so we're going to swap. So over here, we're going to swap between player 1 and player 2. Currently, player 1's active, so it's going to swap to player 2. Swap's going to be set to true. We will create a blaster through its factory, give the input controller its new blaster, and update the bindings on the controller to be whatever the new player's bindings are, and then return swap. So because we did swap players, we are going to go into the grid manager and change our grid. So because we have 2 grids, we're going to swap to the second grid and activate it. Then for swapping player 2, we're going to swap what the current active text is to the second player's text. So if I were to go here real quick, because I didn't showcase this, I will put this here for later. So now we got players 2, so we're going to destroy that. So as you see here, when we go into activating the new grid, we are going to get the current player, and we are going to look at its board. So if we go to P current player, we're going to pull up its board state, and this board state is going to determine where we place our mushrooms. So if I put a breakpoint here, we can see that now we are at row 27, column 0. So that's where it's going to put a mushroom. It's going to do the same thing at 7.2, 9.2, etc. It's going to do that until the grid entity has all of the mushrooms in it. So if we go to grid entity, or entity grid, so we are looking at, right now, we're looking at row 12, column 2. So if we go to 12.2, see there's nothing here. If we go through, now we have a mushroom in that position. And it's going to keep doing this until it populates the entire grid. All right. And then when we deactivate the grid, we just set everything to null. Okay. So I see player one's grid is different than player's two grid. And then if we get hit, we can swap again. So now it's a different grid. And that's it.